Welcome to the Calculus BC video for skill number 257. I can perform partial fraction decomposition. And the trivia question for this video is, in our drivetrain we have this little gear wheel which the chain hooks into as the bike is turning. And I guess the trivia question is, what is this called? This little chain wheel, the free wheel, each one of these different plates, what are they called? Okay, so partial fraction decomposition is not in itself a calculus skill, but it's useful for solving integrals. Let's say we had the rational function 2x minus 1, x squared minus x minus 6. This would be an integral that we could actually solve doing u substitution, and I'd encourage you to go do that on the side. But not all rational functions will work that way. For example, maybe we have one where a u substitution would not work. And so we try integration by parts, and that doesn't work either. But what we do have is we do have a rational function, and so what we can do is we can decompose that fraction. And so this skill is about learning how to decompose that fraction or split it up into a series of fractions which are summed together. Let's take a look at the notes. Okay, so here we are with our video notes. I can perform partial fraction decomposition, and I've kind of given you just a quick image showing what is partial fraction decomposition. You're taking a rational function and you're splitting it into two partial fractions. If we were to add these two together, find the common denominator and add them, they would wind up being equal to this. So let's learn how we do that. I'm going to start with problem number 2, leaving you 1 as part of your homework. Okay, so the first step that we need to take is we need to factor the denominator. Actually, the very first thing you need to do is you need to make sure the power in your denominator is higher. And currently we have degree 2 in the denominator and degree 1 in the numerator. So we're good there. If the degree in your numerator were higher, then what you would need to do is long division of polynomials. And then you could start this process with what would probably be your remainder. But assuming that the denominator has a higher degree, then we can do the process. Step 1 is to factor your denominator. So if we do that in this case, what we'll have is 4x plus 1 over x times x minus 1. Step 2 is you're going to split it, and the way that I'll split it is I'll say I have some term a over x and some term b over x minus 1. Now this will work for all of your linear factors, so x is linear and x minus 1 is linear. If you had an instance where this was squared, then we would need to take a slightly different approach. But the BC test keeps with the linear denominator, so I'm going to focus my approach with those. So at this point, what we have to do is we have to find out some a and b value that would make this equal to that. So let's go and say add those together. So if we were going to add those together, we would have to find a common denominator. So we're going to multiply a by x minus 1, and we would multiply b by x, and that would go over x minus 1, and x times x minus 1. What this means is we can then distribute the a through and the b through. This gives us ax minus a plus bx over our denominator is equal to our original function. So we can then say ax plus bx has to equal 4x, or in other words, a plus b is 4. And then we can also say that negative a is equal to 1. So negative a is equal to 1, which tells us that a is negative 1. And if we know a is negative 1, we can take these two pieces and conclude that b is 5. Because negative 1 plus 5 is 4. Which means when we go back to our split equation, we can take these two values and write this as negative 1 over x plus 5 over x minus 1. And we have succeeded in doing partial fraction decomposition for this rational expression, rational function. If you wanted to multiply it through and check to see that it works, I encourage you to do so. That's always a good thing to do if you have the time. Okay, let's do this for problem number 4. So the first step is to factor the denominator. So this factors to x plus 3 times x plus 1, which means we have a over x plus 3 plus b over x plus 1, and we need to find the values. So shorthand, we can just say a times x plus 1 is plus b times x plus 3 equals x plus 1. So I just kind of left out the denominator of all those steps because in the end we do wind up canceling it. If we start to distribute our an, we get ax plus a plus bx plus 3b is equal to x plus 1, which means a plus b has to be equal to 1. A plus b has to be equal to 1, and a plus 3b has to be equal to 1. When we solve this problem, I like to use elimination, so I'm going to eliminate by subtraction. I'll get negative 2b equals 0, which means b is 0, and if b is 0, a is 1. Telling us that x plus 1 over x squared plus 4x plus 3 is all equal to a over x plus 3 plus b over x plus 1. And that kind of gives us this weird occurrence, because isn't this just all equal to 0? So we're saying that this function is the same as this function. And they may look different, but if we go back to the original form and we see that the factored term x plus 1 would actually cancel, and we're left with 1 over x plus 3. So partial fraction decomposition kind of proved that for us. Alright, let's take a look at one where we're actually required to do the division first. So because the power in the numerator is equal to or greater than the power in the denominator, we're going to have to do long division of polynomials first. And if you wish to use synthetic division, you can do that as well. So either long division or synthetic division. Let's set this up. X squared minus 2x going into 4x cubed minus 3x. Oops. Got to remember to include our missing degrees. I'll do that in red. 0x squared minus 3x plus 5. So how many times does x squared go into 4x to the third? That's going to be 4x times. So 4x times x squared minus 2x is 4x to the cubed minus 8x squared. Then we're going to subtract these. We'll have 8x squared minus 3x plus 5. How many times does x squared go into 8x squared? That is 8 times. So then we're going to multiply that again. We'll get 8x squared minus 16x. And if we subtract those, we'll get negative 3 minus negative 16 is 13x. 13x plus 5. 13x plus 5. And that's the point where we see that x squared no longer goes into 13x. So that's our remainder, which means the partial fraction decomposition of this function is going to be 4x plus 8 plus the partial fraction decomp of this fraction. And that's going to be where you do the partial fraction decomposition of that. So what we have is, in the denominator we have x times x minus 2. So a over x plus b over x minus 2. Which gives us a times x minus 2 plus b times x is equal to 13x plus 5, which means a plus b equals 13, or negative 2a equals 5. And so it looks like we're going to get some nasty values there. But the process would be the same. I'll leave it up to the viewer to tackle this further if they wanted to. Looks like A is going to be 5 over negative 2, and B will be, what is that, some other number. I'll pause it and figure it out. Alright, there's the partial fraction expansion completed. So the 4x, the 8, and then we found A was negative 5 over 2, so there's my A over x, and then I found B to be 31 over 2. So there we go. I've included 2 questions from the BC test, so you can see prior years, some multiple choice examples of what we do with partial fraction decomposition. And they're both evaluating integrals. They're not terribly difficult partial fraction decomps, so I'm going to let you pause it and tackle it and generate an answer, and I will do the same. So go ahead and pause it now. Alright, so I've shown my work. I first split it. A times x minus 2 plus b times x minus 4. That gives me my a plus bx. ax plus bx has to be 0, and negative 2a minus 4b has to be 1. Solving by elimination, I find b is negative 1/2 and a is positive 1/2. So I rewrite it as 1/2 and negative 1/2. And then I evaluated the integral. So I factored out a 1/2, and I had ln of x minus 4, ln of x minus 2. And this answer is not there, but we have to remember our log properties. Because this subtraction sign, we're allowed to rewrite it as a single logarithm of division. I'll leave it to the viewer to work through the second question. And coming back to the fraction that I exposed you to at the beginning, if we were to do partial fraction decomposition for this one, if you wish to challenge yourself, go ahead and pause it. We would probably arrive at the integral of 4 over x minus 3 plus negative 1 over x plus 2 dx. And then we could integrate each of those. Alright, so that's partial fraction decomposition, which in itself is not a calculus skill, but we need to know how to do partial fraction decomposition to solve some integrals that might require partial fraction decomposition. So it's important in that regard. The answer to the trivia question is each of these gear wheels are called sprockets.